All right, we're going to continue to the next section of your test review, which is questions 6 through 14. So here we go. Number 6. The projected worth in millions of dollars of a large company is modeled by the equation y equals 183 times 1.055x. The variable x represents the number of years since 2004. What should the company be worth in 2015? All right, so it has given us the equation, and it's given us the amount of time. We just need to know what to replace x with. So from 2004 to 2015, it has been a total of 11 years. So what we're going to do is we're going to replace that x with the number 11. Okay, we're going to type that into here. 183 times 1.055 raised to the power of 11, and we're going to get that it is worth $329.78. All right, that's how much the company is worth in 2015. Well, actually, I lied, because it's in millions of dollars. So it's going to be $329.78 million. So, good company. All right. Number 7. What is the domain and range of each of these graphs? Okay, so we have our domain of the function, which is our x values, and our range, which is looking at the possible y values. Domain for any exponential always is going to be all real numbers. Okay, so all real x's are going to be involved in this curve. Nothing is stopping my graph from moving to the left or to the right. All right, my range is my y values. What are the y values on this curve? Okay, well, this one has a restriction because I have an asymptote where my graph cannot cross over. And that asymptote, if you can see, is at -4. Okay, so my y's cannot go below -4. So all of my y values have to be greater than -4 to be on this curve. All right. Part B, again, it's an exponential function, so that means all real numbers for our range, our domain, I mean. Our range, all right, well, the curve is down here. It's below my asymptote. This asymptote looks to be at +2. Okay, this asymptote is at 2. So all of the y values on this curve are actually below 2. So here, my range is y's that are less than 2. Okay? Here we go. Number 8. If there are initially 1,500 bacteria in a culture, and the number of bacteria double each hour, the number of bacteria after t hours can be found using the formula n equals 1,500 times 2 raised to the t. How many bacteria will be present after 8 hours? Okay, so again, we need to replace that t value with the number of hours, which is 8. All right, I'm going to plug it into this lovely guy. 1,500 times 2 raised to the power of 8 gives me 384,000 bacteria. Ugh. Right. Number 9. The projected worth of millions of dollars of a large company is modeled by 261 times 1.05 to the x, where the variable represents the number of years since 1997. What is the projected annual percent of growth? Okay, so this is a very fancy way of asking you what's the rate. Okay, how much is it growing? So the rate here, we look at our base, which is 1.05. It is more than the number 1. It is actually 0.05 above the number 1. Okay, I want to convert that into a percent, so I'm going to move my decimal the other way twice. This is going to be a 5% increase each year for this company. Their annual percent of growth is 5% increase each year. Right? Number 10, we're going to write the equation this time to model our situation after 8 years. So that means that my t is going to be 8. Right? Population of 6,500 animals increases at an annual rate of 13%. So this is going to be our p-value. Increasing, meaning we know we're going to do 1 plus my rate. And that rate is actually going to be 0.13 because we make our percent into a decimal, we move it backwards twice. All right, so A equals 6,500 times 1 plus our 0.13. And if we were to actually answer this question, we would replace the t with an 8. But all it wants is just the function, so I have to actually solve it. I'm done. All right, number 11. Find the value of $1,500 deposited in an account that's paying 6.4% annual interest if it's being compounded continuously. Ooh, keyword. Okay, remember the number E is a continuous number. It never stops. So this means we're using our equation of PERT. P times E raised to the RT. Right? This is what we want. 1,500 is going to be my P. And 6.4%, we're going to convert that to be my rate is 0.064. And we're going to plug it into this equation. For part A, my T is going to be 5. For part B, our T is going to be 11. All right? So here we're going to have 1,500 times E raised to the 0.064 times 5. Okay? And this is going to give me, let's see, 1,500. Remember, E is done by doing second and the natural log, which is the button next to the number 4. It's right here. Okay. We're going to raise it to the 0.064 times 5. That's going to give me $2,065.69. All right, part B is the exact same equation, except now we're going to make our T, 6.4. Our T is going to be 11 because now it's been 11 years. So we know it should be more money, right? Because this was only after 5. This one should be more. So we take our same equation. Remember, if you push second enter, your last equation pops up. I'm going to change my 5 to an 11. And now it is $3,032 and about 74 cents. All right, so those were both using the equation with the E. All right, moving on to number 12. Here we go. We have a large city that is growing at 0.9% annually. If there were 1,900,000 residents in the city in 2000, predict how much will be living in the city in these 2 different years. So we've already given you the equation. Okay, all we have to do, just like the last equation, is replace the t value. Okay, what's important is to know that we are starting in the year 2000. So from the year 2000 to the year 2008 means that my t value is going to equal 8. All right, so very large number times 2.7 raised to the 0.009 times 8. What does that equal? 1900, 2.7 raised 0.009 times 8. All right, so this population is now 2040853. And it's 0.31. I'm going to leave it to round down. So our population is about 2,040,853. Okay. Looking to the future, 2019, so now my T is going to be equal to 19. It's been 19 years since the year 2000. Same exact equation. Only difference is that my t is now 19. All right, and let's see what this gives us. So same exact equation, change my 8 into a 19. Here we go. 2,251,700, I'm gonna round up to about 733 people in the city. All right. Moving on to 13. We're going to write a model. So it wants us to create the function after X years. So we don't know the years. It's referring to a tablet that was purchased for $725, and it is decreasing by these different rates. Okay, decreasing means I need to do 1 minus these rates. Remember, 17%, I need to convert that to 0.17. So our model is going to be A is equal to, here's our starting value, 725, 1 minus 0.17 raised to the value of X. If you want to go ahead and simplify this, you could also say A equals 725 times 0.83 X. Both of these are correct. All right. Same equation, but part B has 33% decrease. So remember, that converts to 0.33 as a decimal. So you can say A is equal to 725, 1 minus 0.33 raised to the X, or 725 times 0.67 raised to the X. Both of those are correct. All right, last question for this video. Kevin invested $12,000 into a savings bond, which increases at 7.1% interest compounded quarterly. That means we need the equation where n equals 4, okay, in 2006. In which year did his account reach $7,500, $21,000, and then $30,000? Okay, so we're going to do this one first. We need an equation to start off with. Since it's quarterly, more than once a year, we need to use the equation A equals $12,000 times 1 plus my rate, which is going to be 0.071 over 4, because it's more than once a year, and then 4 times t or x. We don't know the time. We want to know what year is all this happening. All right. So I'm going to put this equation into my y equals function. 12,000 times 1 plus 0.071 divided by 4 raised to 4x. Okay, it's in my y equals. I want to go to my table. Okay, so I'm going to push second graph and go to my table. For the first one, we're looking for 17,500. Okay, so 17,500 is what we're looking for. So when we look in our y column over here, 17,500 looks like it's happening in between year 5 and year 6. So the beginning of year 5 is just 17,000, but beginning of year 6 it has already passed the 17,500. So we know it's going to happen in year 5. So it's between 5 to 6 years, which means it's going to happen in the year 2011, because we started off in 2006, okay, plus the 5 years, it's going to happen in year 2011. And my question asked me, in what year did it happen? So it happened in the 5th year, which is 2011. All right, now I want to know 21,000. So let's see here. 21,000 seems to be happening between year 7 and 8. By the time we get to year 8, it's already happened. So it's happening in the 7th year. So 2006 plus 7 means it's going to happen in the year 2013. All right, last one, we're looking for $30,000 now. So it's going to happen between, let's see here, looks like between year 13 and year 14. So it's going to happen in the 13th year. So 2006 plus 13 gives me 2019 is when it's going to reach $30,000. All right, so that should cover the first half of your test review.